Okay, welcome back. So in the conventional wastewater, we have pre-treatment or primary treatment, screening. It consists of screening, grit and grease removals, and primary sedimentation. And we have a secondary treatment. We consists of several units: activated sludge, activated sludge is one method, uh, erected lagoon, or another method is drinking filter. So number three is sludge treatment and disposal. So in here the primary treatment. In the primary treatment, remove it can remove like about 60% of solid and 35% of BOD. And then in the secondary treatment, so you can see here, this is the activated sludge method. So aeration tank and clarifier, clarification tank. So secondary treatment can remove 85% of BOD and solids. So big portion of the BOD can be removed in this secondary treatment. And the advanced treatment, it vary. 95% of BOD can be removed and solid. 95 plus percent of BOD and solid and NPK can be removed. uh, okay, so this is just the unit. So we have barrack, grid chamber, equalization tank, primary primary settling, yeah, biological treatment, and secondary settling, and tertiary wastewater treatment. Primary treatment involve like screening to remove the light object, and grid chamber. This is to slow down the flow to allow grid to fall out. And number three is primary sedimentation tank. Is a settling solid. Settable solids can settle out with oil floating on top and our skim off. So meaning that the grease can be removed in the primary settling sedimentation tank. The screen is techniques, you know, the screen is first technique to employ in wastewater treatment process. The step is to remove all sort of refuse that have arrived with the wastewater, such as like plastic, branch, rag, material, and metal. The screening process is used primarily to prevent the clogging and interference of following wastewater treatment process. So you can screen have like coarse screen, medium screen, and fine screen. I think we did discuss this one in like in the second week. In the second week, so this is just to remind, to overview it. So if you would like to have uh, detailed information, you can go to the second week material to check the standards of the screen. So the screen, this type of screen called screen bar screen to remove debris from wastewater. Many type of screen can be employed. You can see here. Grid removal. So the purpose of the grid is to remove the heavy inorganic solids which could cause excessive mechanic wear. So grid includes sand, gravel, clay, eggshell, coffee ground, metal, filing, seed, and other similar materials. So this is considered as grid. So grid removal. These items settle to the bottom of the grid channel by gravity. Okay, so grid chamber. In the grid chamber, this is velocity control. So they will control the velocity at the same time to remove the grid. So this is the residual from the grid chamber. Grease removal. Many oil can be recovered from open water surface by skimming device, which is designed to separate the oil and suspended solids from the wastewater effluent. However, hydraulic oil and majority of the oil that have that have degraded to any extent will also have a soluble or emulsified component that will require further treatment to eliminate. Okay, so this is the grease removal. This is design criteria for grease chamber. So depend on the PE actually. So they have depend on the PE. So some PE require a simple one, some require like mechanical automatic one for the grid. Population equivalent. So this we did see this already in my lecture. So P is an estimate of usage made of sewage facility. It is not a measure of population. Okay, so don't confuse with population. This is not a population. This is just an estimate of the usage of the sewage facility. So this one we did show you. So this is design flow. Let's say design flow is 225 liter per PE per day average dry weather flow. So the peak flow factor is this equation. So the peak flow is very equal to peak flow factor multiplied with ADWF. So usually it's like the 225 liter per PE per day, but this one is depend. Okay, it depends on this one. Sorry, this one is 225 liter per day per PE, and then after that PE will be depend on type of establishment like this. Primary treatment. Okay. So this is the wastewater strength of wastewater. Okay, so the for flow measurement. So the flow measurement. Flow measurement is important in the wastewater to control the flow into the treatment plant. So flow can be measured by a measure either as a volumetric quality or instantaneous velocity, which is normally translated into flow rate. So here the flow rate is equal to velocity multiplied with area. Flow rate equal to velocity multiplied with the area. Quantity is flow rate multiplied by time. Okay, and then in practice, the above factor are taken into account by the discharge coefficient, and this is a measure using actual volume flowing through a device divided by the theoretical volume flowing. This together with the measurement of head or pressure. So using area and force of gravity used in vertical flow formula for the calculation of actual flow. So other factor is are taken into account in the derivation of theoretical flow rate formula equation, type of flow, energy of liquid, density of liquid, viscosity of liquid, and temperature of liquid. Okay, so this is like flow. It's how to say, this is like we observe the flow, okay, and then put in a graph. So So this is the flow rate of flow, okay, cubic meter per hour. Okay, this we can see the flow rate, and then this is maximum flow of to full treatment, and this is driver the flow. Okay, so this is standing wave view. Okay, standing wave view. So this is from the plan view. So the water flow in here, and then so we can calculate the flow rate, calculate the flow rate or discharge by using CBH exponential 1.5. So C is the flume constant, and B, that's the width of the flume throat, this one, and H is the head of the liquid over the throat inward. So we have the partial flume. Partial flume is, this is the equation for partial flume. So this is plan view, this is cross section. Okay, we can have a weir, reticular and V notch weir. Usually V notch is easy. You can see here rectangular weir is like 2 divided by 3 CDL square root of 2G H exponential 3. So as long as like here L, you need to know the L, the width. Okay, sorry, L is L multiplied with 0.2 H. Okay, okay, and then V notch is easy, because why? Because V notch is, as long as we know H, see here, as long as we know H here, so everything fine. Solve the problem. Okay. Okay, so we move on. Primary process of grease removal. Grease removal. So this is like, this is the grease, and this is the skim oil to some. Okay. So they will have this equipment will move and to skim off the oil on the top, like this one. This is like skimmer. This is the skimmer to remove the oil. Okay, let us break here, and then we will continue with it next.